Good morning, everyone. Today I am going to present an overview of database management systems using a taxi booking management system as a real world case study. Database management systems are essential for storing, managing, and retrieving data efficiently in the modern applications. In this presentation, we will understand the major concepts of DBMS, including ER modeling, relational databases, SQL, normalization, concurrency control, and NoSQL database. To understand these concepts practically, a taxi booking management system will be used as a real-world example throughout the presentation. Imagine booking a taxi through an app like Uber or Ola. Within just a few seconds, the application identifies your location, finds a nearby driver, calculates the fare, and stores your ride details instantly. But have you ever wondered how all this data is managed so efficiently? That is where DBMS comes into the picture. A DBMS helps applications store, organize, and retrieve huge amounts of data quickly, securely, and accurately. From taxi booking apps to banking systems and e-commerce platforms, DBMS plays a major role in managing real-time information efficiently. Let's see what all functions does DBMS do. Data storage. It stores customer, driver, and ride details efficiently. Data retrieval quickly retrieves ride history and nearby drivers. Data security protects payment and personal customer information securely. Data consistency maintains accurate and updated data across the system. Multi-user access supports simultaneous bookings from multiple users. And backup and recovery recovers write data after unexpected system failures. The traditional file systems often store duplicate data, whereas DBMS reduces data redundancy efficiently. The file systems make searching difficult, but DBMS enables quick data retrieval. Security is weak in file systems, while DBMS provides control access and protection. File systems may contain inconsistent information, whereas DBMS maintains accurate and updated data. Backup management is difficult in file systems, but DBMS supports backup and recovery mechanisms. The architecture of DBMS is as follows. DBMS architecture describes how users interact with the database system. In a taxi booking application, customers, drivers, and administrators act as users. These users interact through the application. The application interface which sends requests to the DBMS server. The DBMS processes the request and retrieves or updates data stored in the database efficiently. DBMS uses different data models to organize and manage information efficiently. The hierarchical model stores data in a tree-like structure, whereas the network model supports multiple relationships between the data. The relational model stores information in tables and is the most commonly used model in modern databases. NoSQL databases are used for handling large-scale unstructured and real-time data such as GPS tracking in taxi applications. Let's discuss about the ER model. The entity relationship model is used to visually represent the structure of a database. It identifies entities, their attributes, and the relationships between them. This ER diagram represents the structure of a taxi management system database. The main entities include customer, booking, driver, vehicle, and payment. Each entity contains attributes along with primary keys and foreign keys for identification and relationship. A customer can make multiple bookings, while each booking is handled by one driver and one vehicle. Similarly, each booking is associated with a payment record. The relationships shown here help organize and connect the data efficiently within the database system. After designing the ER diagram, the entities are converted into relational schemas or database tables. Each table contains attributes along with the data types and constraints. Primary keys uniquely identify each record, while foreign keys establish relationships between the tables. For example, the booking table contains customer ID, driver ID, and vehicle ID as foreign keys to connect bookings with customers, drivers, and vehicles. Similarly, the payment table is linked with the booking table using booking ID as a foreign key. These relationships help maintain consistency and integrity within the database system. Relational algebra. Relational algebra operations are used to manipulate and retrieve data from relational tables. Selection filters rows based on conditions, while projection retrieves only required columns. Join operations combine data from multiple tables, which is commonly used in real-world applications. Union combines results from different relations. Difference identifies unmatched. Difference identifies unmatched records, and Cartesian product generates all possible combinations between the two tables. The SQL commands are classified into different categories based on their functionality: DDL, DML, DQL, and DCL. DDL or data definition language is used to define and modify database structures using commands like create and alter, where DML data manipulation language is used to insert, update, and delete data from tables. DQL is mainly used to retrieve data using select queries, while DCL controls user access and permissions using commands such as grant and revoke. Now let's discuss some constraints. SQL constraints are used to enforce rules and maintain data integrity within database tables. Primary keys uniquely identify each record, while foreign keys create relationships between tables. Not null constraints prevent empty values. Unique ensures there are no duplicate entities, and check validates specific conditions. Default constraints automatically assign predefined values when no value is provided. These constraints help maintain accurate and reliable data in database systems. SQL joins. SQL joins are used to combine data from multiple related tables. An inner join returns only matching records from both tables, while a left join returns all the records from the left table, even if matching data does not exist. Similarly, right join returns all records from the right table, and full outer join combines all records from both the tables, displaying null values wherever relationships do not exist. In taxi booking systems, joins help connect customers, drivers, bookings, and payment information efficiently. Subqueries and views. Subqueries are queries written inside another SQL query and are useful for retrieving filtered or dependent data. For example, this query identifies customers whose booking fare is greater than the average fee, and the below query finds the drivers with no completed bookings. Views are virtual tables created from SQL queries and help simplify complex data retrieval operations. In this example, a view is created to display completed ride details, which can later be accessed like a normal table. Triggers and cursors. Triggers are automatic database actions executed whenever specific events occur. For example, in a taxi booking system, a trigger can automatically update a driver's rating after a ride review is submitted. Triggers are commonly used for validations, automatic updates, and maintaining database consistency. Cursors, on the other hand, process records one row at a time. They are useful for tasks such as generating driver bonus reports, processing unpaid bookings, or creating monthly statements individually. When large amounts of repeated and unorganized data are stored in a single table, several problem occurs, known as anomalies, can occur. Here, customer, driver, and vehicle table details are repeatedly stored inside the booking table, causing data redundancy. If a driver's information changes, multiple records must be updated separately, which may lead to update anomalies. Similarly, insertion and deletion anomalies can also occur, resulting in missing or inconsistent data. To solve these issues, the data is divided into separate tables such as customer, driver, vehicle, and booking. This process is called normalization. The first normal form or 1NF ensures that every column contains only atomic or single values without repeating groups. After applying 1NF, the booking table becomes more structured and organized. Second normal form or 2NF removes partial dependencies by separating data into multiple related tables. Here, customer and driver details are moved into separate tables because they depend on their own primary keys rather than the booking ID. This reduces redundancy and improves database consistency. The third normal form removes transitive dependencies from database tables. In 3NF, every non-key attribute should depend only on the primary key and not on other non-key attributes. To achieve this, customer, driver, vehicle, and pickup location details are separated into dedicated tables connected using foreign keys. As a result, the database becomes more organized, reduces redundancy, and improves consistency. The fourth normal form of ONF removes multi-value dependencies from the database tables. In this stage, independent multi-valued information is separated into dedicated tables to avoid redundancy. Here, booking and pickup location details are organized separately so that independent values are not repeatedly stored together. As a result, the database becomes more flexible, scalable, and easier to maintain. The 5NF, also called project joint normal form, removes complex joint dependencies from database tables. In this stage, the database is divided into smaller related tables so that each relationship is stored independently. Associative tables such as booking pickup and vehicle pickup help maintain relationships without introducing redundancy. As a result, the database becomes highly structured, scalable, and free from complex dependency issues. A transaction is a sequence of database operations executed as a single unit of work. In a taxi booking system, booking a ride involves multiple operations such as creating the booking, updating the driver status, and updating the vehicle status. If all operations complete successfully, the transaction is committed permanently. However, if any operation fails, the transaction is rolled back and all the changes are undone. This ensures data consistency and prevents partial updates in the database. Asset properties. Asset properties ensures that the database transactions are processed reliably and accurately. Atomicity treats all operations as a single unit, meaning either all changes are applied or none are saved. Consistency ensures that the database remains valid before and after transaction. Isolation prevents concurrent transactions from interfering with one another, while durability guarantees that committed data remains permanently stored even after system failures. Concurrency control. Concurrency control manages simultaneous database transactions and prevents conflicts when multiple users access the database at the same time. In this example, two customers attempt to book the same driver simultaneously, resulting in the lost update problem where one transaction overrides the another one. To prevent such conflicts, DBMS uses techniques such as locking, timestamp ordering, and recovery logs. Locking ensures only one transaction accesses a record at a time. Timestamp ordering maintains transaction order, and WAL helps recover data during failures. These mechanisms maintain consistency, accuracy, and reliability within the database system. NoSQL databases are non-relational databases designed for handling large-scale and flexible data efficiently. Unlike traditional relational database, NoSQL systems support schema flexibility and horizontal scalability. Different types of NoSQL database include key value, document, column family, and graph database. Modern applications such as ride-sharing platforms and real-time taxi tracking systems commonly use NoSQL database for high performance and scalability. In conclusion, database management systems play a vital role in storing, organizing, and managing large amounts of data efficiently. Through the taxi management system example, we explored important DBMS concepts including ER modeling, relational databases, SQL, normalization, transactions, concurrency control, and NoSQL database. These concepts help build reliable, scalable, and efficient real world applications. Thank you.